When the foundation is faulty, what can the righteous do? Solving geometry question is somehow difficult and tedious when you don't know the basics. You are welcome to Dynamic Educational Hub channel, your answer to the very question. And in this video, we are going to learn the basics, the elementary parts of geometry. So we are going to look at lines, angle, and various types of angle and forms of angle. This is the first video in this playlist, and if you haven't subscribed to my channel, kindly subscribe to my channel. Click on the notification icon to get notified when I release new video. You can also check out my various playlists in this channel. Without wasting time, let's start the video. The first thing which we want to learn in Euclidean geometry is line. What is line? A line is a continuous point. And we have different types of line. We have continuous line, like the name, continuous point. Example of continuous line is when we have a straight line, when we have a zigzag line, and a curve. Now this is an example of line. When you pick a point and the part of that point is being continued, there you go, you have a line. We also have another point that is moving in a wavy pattern following a straight line. The name of that line is known as zigzag line. It's also a continuous line. There is no breakage. We have continuous line means no breakage when the line is being drawn. We also have discontinuous line. Discontinuous line are known as dashes. This is an example of discontinuous line, and if you look at it very well, we are able to see some gaps between the lines. That is why it is discontinuous. We also have curve. Curve is also a line. You can say it's also a line, but because it is also a continuous point, that is why I classify curve as a line, and I also classified it as a separate entity. And this is an example of curve. So we have continuous line, discontinuous line, and we have curve. Everything is still under line. We have various forms of line, relationship between lines. The first one we want to look at is perpendicular lines. A line is said to be perpendicular to another line when it intersects another line to form right angles. Right angles means 90 degrees. So when you have intersection of two lines, and at the point of intersection, they are able to form right angles, 90 degrees. So like we have in this diagram, let's have a line and let's have another line that intersect this line. Now the point of contact, it forms a right angle. That is why we call it perpendicular line. So it means that this line is perpendicular to this line. So if you also extend it further, you see it's cut across it. So we also have a perpendicular line. Now let's have another straight line as shown. And we have another line that intersect this line. At the point of intersection, they form 90 degrees. So the two lines are perpendicular to each other. This is what we call perpendicular line. Perpendicular line is not only drawn straight like this. When you have a line, regardless of the orientation of that line, and another line cut across that line, it's 90 degrees. So it means that that line is perpendicular. Perpendicular also has a symbol in mathematics. When you see this symbol in mathematics, it shows that two lines are perpendicular to each other. They are inclined at angle 90 degrees. We also have parallel lines. So what are parallel lines? Lines are said to be parallel to one another when they are not converging or diverging. Mark that word, converging or diverging, which means that they can never meet or cross one another's path. You have lines, maybe two lines, and the part of that line is not cutting across each other's. So it means that the two lines can never meet, and it is said to be parallel lines. The lines are parallel. This is an example of parallel lines. This arrow here is showing that this line is parallel to this line. So that is one of the things you have to look for when you are doing mathematics. When you are solving geometry question, you look for this arrow. When you have an arrow here, you also have the same number of arrow in another line. It shows that the two lines are parallel to each other. We have non-parallel lines. Lines are said to be non-parallel to one another when they are converging or diverging. Unlike parallel lines that are not converging and diverging, non-parallel lines are converging. Converging means they can meet at a point or cross each other's path when extended. So when lines are converging, it means that the two lines, there will be a point at which the two lines will cut each other's path. Either you extend the two lines forward or you extend it backward. So let me explain this. When you have a straight line moving that way and you have another straight line moving this way, if you look at these two lines carefully, you discover that although the two lines are not intersecting, but when you extend them like this, you see that later on they are going to intersect each other. So that is why these two lines are non-parallel lines. You can see that they are moving towards a certain point. That is what we call converging. Let's have another line like this. We have another line like this. If you look at the movement of the two lines forward, you discover that these two lines are moving away. They are not going to cut each other's path when you follow their paths along the right hand side. But when you are able to trace their paths, when you retrace their path backward like this, you discover that they cut each other's paths, which means that this line are diverging line. They are non-parallel lines. For non-parallel lines, when a lines are being drawn either to form a shape or you just have a diagram and you have lines, there's no arrow on the two lines. There's no arrow. It shows that those lines are non-parallel lines. That is the implication of that. We also have another line that is known as transversal line. What is the meaning of transversal line? A line that cuts or passes through two parallel or non-parallel lines in the same plane. So when we have two lines like this, for instance, you can see an arrow here, an arrow here. These two lines are parallel to each other. When you now have an external line that cuts across them, the name of that line is known as transversal line. Line that cut across two traveling lines or that cut across multiple lines. When it cut across them, it's going to form angles. And if you look at transversal line to two parallel lines, if you look at this diagram, look at this color here, it shows that this angle is equal to this angle. This angle over here is also equal to this angle. That is the implication of that. Let's have transversal line to non-parallel lines. We have two non-parallel lines like this. Let's have a transversal line across them that cuts them. Now we also have angles here. You can spot the difference between when transversal line cut across parallel lines and when transversal line cut across non-parallel lines. Transversal line to non-parallel lines will form angle that does not have relationship with the other angle over here. So that is why this one is green. This one is also green, opposite angle. But you see that the color of this one differs from this one. It's showing us that for non-transversal line, this angle is not equal to this angle. So that's the meaning of plane in Euclidean geometry. What is plane? A plane is a two-dimensional flat surface or space or area that is defined by points in coordinate system and it extends indefinitely. For you to understand plane very well, plane is just like a flat surface, a space. When you have a flat surface, then you can say we have a plane. Now to understand it, let's have coordinate system. We want to have Cartesian coordinate system, which is x and y, or rectangular coordinate system. So we have y-axis here, we have x-axis here. So let's have some mesh, just like graph. We have mesh like this. Now, if you draw any shape here, it means that you are drawing it on xy plane. So we have a shape here. This is a plane. This is another plane. And they are being drawn on xy plane. This is a shape drawn on xy plane. We have another shape here. We have another shape here. Now, all these shapes, you can simply say that they are plane. That is why we used to call them plane shape, plane figure, two-dimensional plane shape. So, because when you draw them, you are drawing them on xy plane. That is why we call them plane figure. We need to talk about another coordinate system. Let's have 3D coordinate system. So let's have x-axis here, y-axis here, and z-axis here. Now this is 3D. Now let's have a plane here as shown. Now this plane will be zx plane or zx plane. Why is it zx plane? You can see that this plane is changing along z-axis like this and changing along x-axis. So that is why it is called zx plane or xz plane. So better still, xz plane. Now let's have an object here. This is a 3D object, just like a ball here. Now let's close up this shape. Now closing it up, let's have a plane here. Now this one, if you look at it carefully, you will observe that it is changing along y-axis, increasing along x-axis. That is why we call it xy plane. This face, this two-dimensional space is now called xy plane. Now if you cover this side as well, it's changing along z-axis or z-axis and y-axis. That is why it's called zy plane or yz plane. Zy plane or yz plane. Now if you cover the top part, the same thing is changing along z-axis and along x-axis. So you can call it xz-axis or zx plane. Now this is zx plane or xz plane. That is the meaning of plane. You can have plane using 3 coordinate system to define plane. You can also use 2 coordinate system to define plane. Plane is different from location of an object. Let's quickly talk about angle and its classifications. Now, angle is formed by the intersection of straight line, and for plane shapes, angle is formed at the vertex of a plane shape. If a plane shape is having multiple vertex, which means vertices, the angle will be formed at the corresponding vertex of a plane shape. Let's have a plane shape which is a triangle. Triangle is having 3 vertices. So we have one vertex here, so angle will be formed here, angle will be formed here, angle will also be formed here. That is why we call it triangle. Now for straight line, angle is formed when 2 lines or multiple lines intersect. At the point at which multiple lines intersected, an angle is being formed. Let's say we have 2 straight lines which join each other here. The angle will be formed at the point, so which means we have an angle formed here. Angle has many classifications, so I grouped classification of angle into 3 categories. Now we have angle here, so I group it into value, formation, and range. So I'm going to start with range. Now classification of angle according to range. Range simply means when we look at the highest value of angle and the lowest value of angle, when you look at the span of angle. So we can classify angle into 4 categories here, which is acute, obtuse, right, and reflex. When we look at the size, the range of angle. Now when we look at the value is coming from when we sum up different angles together. When we add them together, that is the classification I use. So adding angles together, we have complementary angles, supplementary angles, and explementary angle. We also have formation. How is angle being formed? Now when we have transversal line across two parallel lines, we can use it to form different angles, and we can relate the angles together. The relation, the formation, we have alternate angle, corresponding angle, opposite angle. That is the classification I have over here. So let's learn complementary angles. What are complementary angles? Angles sum up to right angle, which means 90 degree. When you add angles together and you get 90 degree, then you can see we have complementary angles. Example of complementary angles: when we have two lines that are perpendicular to each other, remember that the angle that will be formed by the two lines is going to be right angle, isn't it? So when you now divide this angle by multiple line or a single line, multiple angles will be formed. We are going to have two angles. So when you add these two angles together, then you say you have a complementary angle. So if this one is A and this one is B, when you add it together, you get 90 degrees. So which means we have a complementary angles. The same thing applies to right angle triangle. Remember, for right angle triangle, one interior angle would be right angle. That is why we call it right angle triangle. This angle is 90 degrees. So when you now add the other angles together, you should get 90 degrees. So I have it in trigonometry. Now if this one is B and this one is D, when you add B and D together, you're supposed to get 90 degrees. So which means complementary angles. So A plus B from this will give us 90 degrees, and P plus D from this will give us 90 degrees. That is complementary angles. Why is it called complementary angles? I have an explanation on trigonometry. You can go and watch it if that video is available at the time at which you are watching this video, but it will later be available in trigonometry playlist. So the reason why it is called complementary angles, when we add angles together and it's 90 degrees. The next angle is supplementary angles. Now angles sum up to 180 degrees, which means that when you add angles together and you are getting 180 degrees, then sum of angles are supplementary. They are supplementary angles. Example of supplementary angles are sum of angles on a straight line and sum of interior angles of a triangle. So let's have sum of angles on a straight line. Let's have a straight line. Now the angle that will be formed on this straight line is 180 degrees, just like a diameter dividing circle into two equal parts. So we are going to have 180 degrees. And if you now try to join this another line with this straight line at a point, and you have multiple lines, it means that you have divided this 180 into set of angles. So that is why we are going to have this. Let's call this beta, let's call this theta, and let's call this gamma. Now if you add all these angles together, what are you going to get? We are going to get 180. That is why we call it supplementary angles. When you sum angles together and you're getting 180, then we have supplementary angles. We also have sum of interior angles of a triangle. Now a triangle is going to have three interior angles, like the name implies, triangle. Now let's label those angles delta, gamma, and beta. That is the interior angle. So when you add it together, you're supposed to get 180 degrees. So which means that while proving the sum of interior angles of a triangle, we are going to see that this set of interior angles align on a straight line. So we are still going to do that, proving the interior angles of a polygon. The next angle is explementary angles. What are explementary angles? Angles sum up to 360 degrees. So when you add up angles and you are getting 360 degrees, then you said we have explementary angles. Example of explementary angles are angles meeting at a point and sum of interior angles of a quadrilateral. Don't forget, quadrilateral is a four-sided polygon. Now let's have a point here as shown, and let's have several lines passing through that point. So which means that we have different lines intersecting each other. Several angles will be formed around this point, and if you add those angles together, you will get 360 degrees. We are still going to do this. This one is A, this one will also be A, opposite angle. This one is B, this one is B, opposite angle. This one is C, this one is C, opposite angle. So which means that we have 2A plus 2b, angle around this point 2a plus 2b plus 2c, and that is going to give us 360 degree explementary angles. The same thing applies to all these four-sided polygon, which is quadrilateral. Now this one is a rhombus, this one is a parallelogram, this one is a square. So all the interior angles, when you add them together, you will get 360 degree. Let's start with ranges of angles. When you classify angles according to range, you have acute angle. So acute angle, you can see two lines here intersecting each other and an angle is formed here. Acute angle is angle that is less than 90 degree. Theta is a Greek symbol that is usually used for denoting angle. So theta is less than 90 degree. So any angle that is less than 90 degree is classified as acute angle. 30, 60, 45, 85, 8. So we have obtuse angle as well. Obtuse angle, they are angle that range between 90 to 180. So it means that between 90 point something to 179 point something. So any angle that falls between this range is known as obtuse angle. Example of obtuse angle is any angle that is greater than 90 degree. That's 91, 97, 120, 117, 150, 179. So they are all classified as obtuse angle. Now just look at these two diagrams. You can see acute, very small, obtuse, big, more than 90. Now the next one is right angle. You come across this one, we also have right angle triangle. Now right angle is any angle that is equals to 90 degree. So when you hear the word right angle, it means 90 degree. So any angle that is 90 degree. When you hear the word right angle triangle, it means that one of the interior angles is 90 degree. When you hear the word right angle isosceles triangle, it means an isosceles triangle that is also right angle triangle. So which means one angle is 90 degree. So lastly, we have reflex angle. For reflex angle, this angle is in between 180 and 360. Any angle that is greater than 180 becomes a reflex angle. Now for reflex angle, to get a clear understanding of reflex angle, when you are measuring the outside portion, when two lines are intersecting each other and you are measuring the outside portion, the angle of the outside portion, you are reflexing the angle. So which means what you get is a reflex value of angle. You see that the angle that we are measuring here is inside, acute. The one that we are measuring in here is also inside, obtuse. The one we are measuring here is inside, right angle. But for reflex angle, you see that it's outside. So if you decide to measure the angle outside here, you are reflexing the angle. That is we are going to get a reflex angle. And if you decide to measure the angle here, that's a reflex angle. When you decide to measure the angle outside here, that is a reflex angle. So reflex angle, example of reflex angle: 181, 220, 230, 259, 286. Any angle between this range, they are known as reflex angle. Over to another form of classification of angle, which is formation corresponding angle. When you hear the word corresponding angles, it means angles occupying similar position, and corresponding angles are equal. To understand corresponding angles, we are going to be using parallel lines. So like I've explained earlier on, formation of angles, we are using parallel lines to form angles here when you have a transversal across two parallel lines or multiple parallel lines. So the first one is we are talking about corresponding angle. Let's have two parallel lines as shown, and let's have a transverse line. Now angle occupying similar position, this line is going to form angles here, some angles here, and some angles here. So we have four angles being formed here. We also have four angles being formed here. Corresponding angles are equal, so which means that angle occupying similar position, if you cut this into two, you see this one over here, this angle will be the same thing with this angle over here. So if this is 50, this one is also 50. Please know this. This is corresponding angle. We'll be needing this if we are solving and you are proving some formulas or some theorem in geometry. We'll be needing all this. The next one is, if you look at this angle very well, which automatically will be equivalent to this, will be equals to the angle that is facing it. This one. This is opposite angle. Now we are still talking about corresponding angle. This angle will now correspond with this one because they are being formed, they occupy the same position. And this one, so this one will be equals to this one as well, corresponding angle. The next one is the angle here will also be equals to this angle. Finally, this angle here will be the same thing as this angle. So that is corresponding angles. They are equal. We also have alternate angles. What is alternate angle? When parallel lines are cut by a transversal line, the angle formed on the alternate side of the transversal are called alternate angle. So let's have parallel lines and let's have a transversal line. So it's going to form multiple angles as shown. And if you pick this angle, the other side here is the alternate part of this transversal line. This is one part, this side, the right hand side, and this is another side, the left hand side. So if you pick angle here, the alternate angle to this angle will be the other side, which is this angle. So this is what alternate angle means. Alternating. You have one here, you have one here, so and they are equal. You also have many alternate angles here. Let's pick this angle and let's look at the one that is alternate to it. Look at the position. You move to the other side again. This one becomes the alternate to this one, and they are equal. If this is 40, this one will also be 40. If this one is 50, this one will also be 50. Let's look at another alternate angle here. Let's have this. Now over to this one. This one is quite interesting. You look at this one. So the opposite side, right? The other side. And you have something here. So you move to this place again. So this is the alternate angles to this one. Now let's look at the final one. Look at this one here. It's this one. And they are also equal. That is alternate angle. Get this. So you won't have issue solving geometry question and even circle geometry question. Looking at this diagram, you can have rotation. What you just need to do is understand corresponding angle, similar position, and understand alternate angle when you have other side. For instance, if you are talking about corresponding angle, this green here will be the same thing as this blue here, corresponding angle. This red here, this wine here will be the same thing as this brown here, corresponding angle. This blue here will be the same thing as this green here, corresponding angle. And this brown here will be the same thing with this red over here, corresponding angle. The same thing with this green over here, it will be the same thing as this blue over here, corresponding angle. If you are talking about alternate angle, other side, so this green here will be the same thing as this green here. It's alternating. You have one facing here, you have another one facing here. So this red or wine here will be the same thing as this wine here. So this one here will be the same thing as this one here. So another way is when you look out for your Z and N. Looking for Z and N will quickly enable you to picture the alternate angle. So this is Z here. Let's have N here or H. So if any angle that is at this point will be the same thing as this point. So now let's look at an example. Find the relationship between angle A to angle L in the diagram below. What we want to do is we want to equate them and use what we have learned so far to explain why this one is equal to this one. Let's go. Let's start with A. we can say that A here is equals to C. Why is A equals to C? Opposite angle equal. You can also say this A here is equals to this E here. Why? Corresponding angle. Angle occupying similar position. This A here is also I. Why? Corresponding angle, similar position. So let's look at alternate of this A. A is alternate. Look at A. You move to the other side. It's alternate to G. Alternate angle. A is equals to G alternate angle. This same A, if you move to the third part, it's also alternate to K. Alternate angle. A is equals to K. We are done with A. Let's move to B. B is equals to D. Opposite angle. B here is also F. Why? Corresponding angle, similar position. B here is also J. Why? Corresponding angle, similar position. B here will be equals to H. Why? Alternate angle. B here will be equals to I. Why? Alternate angle. Look, carefully observe this line. They are parallel lines and we have a transversal line. So we are through with B. Now let's pick C. C here will be equals to A. Opposite angle. C here will be equals to G. Corresponding angle. C here will be equals to K. Corresponding angle. C here will be equals to E. Alternate angle. C here will be equals to I. Alternate angle. Finally, let's pick D. D here will be equals to B. Opposite angle. D here will be equals to H. Corresponding angle. D here will be equals to L. Corresponding angle. And D here will be equals to F. Alternate angle. D here will be equals to J. Alternate angle. So K, let's look at K. It seems I've not talked about K. Angle K here will be equals to I. Why? Opposite angle. Angle K here will be equals to G. Corresponding angle. K will be equals to C. Corresponding angle. K will be equals to E. Alternate angle. K will be equals to A. Alternate angle. Same thing with L is equals to J. Opposite L is equals to H. Corresponding L is equals to D. Corresponding.
We've come to the end of this elementary Euclidean geometry class, and before I take my leave, I would like to do a quick recap of what we have learned so far. In this video, we are able to learn line and various types of line. We looked at the meaning of angle and we classified angle according to the value, according to the range, and according to how it is being formed. We also look at corresponding, alternate, opposite angles, complementary, supplementary, and explementary angles, acute, obtuse, reflex, and right angle. If you haven't subscribed to my channel, kindly subscribe to my channel, like my video, share my video, and in our next video, we are going to start using what we have learned to solve different questions in Euclidean geometry. Thank you for watching this video. Bye for now.